Hello, testing. I think we're live now. You guys can see the keyboard, right? Let me just make it a little bit better. Hello, everyone. How is it going? I'm going to do the stream a little bit differently today. Probably not going to put any songs on just because I keep having issues with copyright. So I'm gonna do it without any music. But you guys let me know if you prefer music. I can put it on in the middle of the stream. It's not a problem. Let me see if I'm actually live though, because YouTube hasn't yet.
Wild with generative AI.
I'm getting adverts on my own stream. Nice. Anyway, I can see there are some people waiting already. 7 people waiting. That's probably the most we've ever had. So thank you all very much for clicking on the on the watching now or notify me a button. Let's see. Thank you all very much for clicking. There you go. I can hear myself. Hello, Robin. Hello, Vinay. Let me make sure that I can hear myself through the speaker, not through the headphones and not the speakers. That would be amazing, wouldn't it? There you go. I'm connected now. I don't think I can dox myself with anything here. I've only got a calculator. You know, everything seems fine. Okay, good. Yeah, welcome everyone. Welcome. Hello, Brock Daniel. Today we're going to be doing some C++ on the stream. In fact, we're going to work on some of the 65OK code that we've been developing in the past. In fact, it's been a project that I've kind of enjoyed working on it myself outside the stream. I've actually implemented quite a few things since the last stream. Like it's mostly just new instructions. So for those who don't know, I'm writing a 6502 emulator in C++. And 6502 is just one of those very old processors that some computers back in the day, 8-bit computers, used, as well as consoles like the NES and the Super NES as well. And it basically just boils down to implementing the instructions in C++, right? So what I do is essentially I go on Google and I search for 6502 instruction set, and I go on this very helpful website, Masswork. If you guys are kind of willing to do the same thing, Masswork is a very good source. It has all the instructions. You click on any of them and it'll show you exactly what they do. And that's what we're doing. That's what we do in C++. So there's a very, very long file with all the functions for the instructions implemented here. And I've got some unit tests to make sure that those functions actually, or the instructions actually do what they're supposed to do. And yeah, let's get on with it. Now, we do have a few example programs here that we can run. So for example, if I've not broken anything, there's some binary files that we can run through this, which are basically just compiled in 6502 instructions down to binary, and the program reads it in and just draws things on the screen basically. And in fact, Robin is on now. He did a few of the programs that I'm going to run today. So let me just show you kind of what it does. Let me see if I can change this. And if you run it, you can kind of, there you go, Robin. Yeah, your program is going to live on forever, dude. There you go. So it just draws graphics on the screen, right? That's all we do at the moment. And yeah, I mean, the idea for this is, you know, it's gonna be a long shot, but maybe in a few months we're gonna have a fully working NES emulator. So this is kind of what the emulators do, right? Yeah. So let's get on with it. At the moment, what I would like to do on the stream today is to implement the cycle counting and timing, right? So what do I mean by that? Each of these instructions that the 6502 can run, for example, if we take a very simple example here, ADC absolute. So ADC just adds whatever's on the memory to the accumulator, and then it sets a flag, like a carry flag if it overflows, or, you know, you get the gist. So each of these instructions actually have a cycle attached to it. So these cycles essentially tells the user how long the program will take, right? Because you can add up all the cycles, and, you know, if done properly, emulation should take the exact same amount that the original hardware would take, right? Now, this is actually something that's it's not very easy to implement. I've actually looked up online, and, you know, there isn't a single way people kind of implement these things. But that's what we're going to be implementing today. So we're going to be making sure that each instruction actually takes the amount of time it's supposed to take. Now, obviously, if I'm running on my computer, and if I do, for example, an ADC operation here through my emulator, it's going to take, you know, much the time taken for that instruction is going to be much quicker than it actually takes on the original hardware. So for example, the 6502 or 6510 emulators, I think the NES is actually 6510, I'm not too sure, but if we do 65K NES processor speed, you can see how many cycles it can do per second. So usually, let's see here if we can actually find it. It should be like something, yeah. I mean, Wikipedia is saying that it does 3.58 megahertz, right? So this doesn't mean it does, 3.5 million instructions a second. It does mean that it does 3.5 million cycles per second, right? So for example, if we were just doing ADC instructions over and over again, it could do that number divided by 2, right? Because each instruction takes 2 seconds. So that's what we're going to be implementing today. And one of the, I guess the easiest way to kind of do this is by looking at how we're actually representing each instruction, which in my case, it should be something like just a simple lambda for each instruction, if I'm not mistaken. Oh, these are the tests. Let's actually go to the emulator.cpp file. So you can see that I have, the structures, the struct for the registers, which is where we store the, the operation data here. So very, very fast access operations, very, very fast access data is installed here. We have the flags in the CPU that the instructions set as well. And we also have this kind of instruction type def here. And this is what I use in the code to represent a particular instruction. So you can see that each instruction is just represented by a function pointer. So either a lambda or something like an actual function pointer itself. And, each instruction takes in the CPU. The CPU is just, the collection of the registers and the flags as well as the program itself, right? So with that information, we can execute anything. Now, what I don't have here is some way to represent the number of cycles that a particular instruction takes, right? So there is a size t that's returned here. So we return a size t, which represents, if I'm not mistaken, the number of bytes that we read from the program, right? From the current pointer, from the current program pointer, and then if we read an instruction that takes 2 bytes, for example, ADC in absolute mode, which takes the instruction itself, which is represented by a byte. So you can see here which byte is actually used to represent. So 69 in hexadecimal, and also the data that you want to add to the accumulator, right? So in that case, it would return 2 in this case. Hello, John Spenny. Hello, John. It's good to see you, man. Hello, I find myself looking at the keyboard. I find it a bit distracting for me at least. Yeah, I mean, let me know if it's too distracting. I can remove it from the screen as well. I mean, it's not necessary, but let's just see how we get on, John. And if it's still too distracting, I'm fine to remove it. In fact, yeah, no, I'll keep it on for now, John. But like, let me know if it's too much. It's too much. We can get rid of it. So a good place to actually implement this would be here, right? So instead of returning a size t, we could return a size t for the number of bytes that we kind of read, and also a size t for the number of cycles that it's supposed to take, right? So we're gonna do just that, right? So yeah, let me think about this now. So I mean, there's nothing saying that no one's stopping us from just including the tuple here and just returning it an optional tuple. So let's do that. By the way, if you guys want me to add the music as well, please let me know. I've kind of removed the music today just because I keep getting issues with YouTube where I'm streaming something and then like 50 minutes into the stream I get a copyright song and I'm not able to show you guys adverts anymore, which means I don't really get much money at all. But I'm happy to put the music on if it's better, right? So Mark A says, "Oh, right." So I'm guessing that's a yes to music, right? So yeah, please let me know, guys. If you want the music, just put it in the comment section, and I'm happy to add it back. But anyway, before we start, I just want to ask you, like, how are you guys been? It's been basically, I think, 5 days since the last stream. I think last time I streamed was on Monday, if I'm not mistaken, last Monday. So it's been a long time. I've not actually spoken to some of you, and I hope that you've been doing well, and I hope that you've been actually doing some code as well, practicing. So yeah, let's go for it. Right. So I'm going to add that tuple header, which if I'm not mistaken is the utility header. If we don't already have it in here somewhere, and let me make sure that it's all kind of in order. And now we can go down here, and this is actually going to end up looking very, very big. So it's going to be a tuple of size t, and also we're going to have another size t, std size t, right? So yeah, I mean, it's, you know, at this stage it's probably worth actually explaining what this is, just for people who want to kind of see the code later. Which, by the way, if you are interested in looking at the code, I do have the link down in the description somewhere. It just takes you to the GitHub page of this project, which is 65k CPP here. And this is where you can see all the code. You can see when I push stuff, and you can kind of run it for yourself if you want. It's actually very portable. I've built this on Windows, Linux, and you know, no issues basically, because there's very few dependencies, so you have nothing to worry about. It's just basically C++. But yeah, check it out. The link is on the description there. Also, as a bit of a plug, if you guys can like the video, I would appreciate it very much. It does help out with the algorithm. So yeah. Yeah, so instructions are represented with function objects, right? That return a tuple of, and then we can say here, so this would be the bytes read from program. And we also have, as I said, we're going to put a cycle in there. Now, this simple change is going to break my entire program. So if I actually try and build it now, everything will be broken, right? So you can see that every single instruction is now broken because they just return that particular, the bytes read, right? So, you know, there's nothing we can do here. Now, let me think of the best way to actually approach this. Because this actually, you know, it looks to be a very simple change here. But if you look deeper into the 6502 instructions, particularly if we go into the Masterwork website, which I actually accidentally closed. I do this every time on stream. I hate how I do this every time on stream. Every time I kind of close the tabs I actually needed the most all the time. So, you know, some of these instructions are fairly straightforward. So, for example, I was talking about ADC, and if you look at ADC here, absolute, you can see that they take, you know, the immediate mode here where you actually provide the particular data you want to add inline in the code. It takes 2 cycles. But then once you move on to a different mode, so for example, the 0 page here, there's a 0 page mode, it takes 3 cycles, right? And it takes 4 cycles there. And it gets even more difficult when you actually look at operations that can kind of move the pages of the program, right? So I'm trying to, maybe we can draw a little diagram here for you guys to kind of understand what I mean. So, all right, Excalidraw is kind of freezing to me, but say we had a few lines here. This is the memory of the CPU, right? So the memory of a 6502 processor. Let's say this is a, so we kind of have something like this, where each kind of cell is a byte that you can access, right? This is essentially what we have. We're just like moving memory around. That's all it is. So it's going to take a while for me to draw. Bear with me. It's going to be worth. The representation is going to be worth it. Guarantee you. So something like, oh my god, I have to. What I don't like about Excalidraw is that you have to select the tool every time you've changed to like a mouse view or something, which is kind of annoying, really. But yeah, you know, say this is the memory of a particular 6502 CPU, right? So this here is memory address like 00, right? 0x00, right? Something like that. And the next one is going to be, as you can probably guess, 0x01. If we can draw an arrow. So this one here is going to be something like 0x01, 0x01, and so on and so forth, right? You get the gist. So we move on to the next cell, and that is 0x02. Now, one page here, a page is defined as basically FF bytes, right? So say that we had this number of bytes here, so FF, that's going to be 256 if I'm not mistaken, right? Let me see now, FF. If we do FF here, there you go, 256 different bytes if you count 0 as well, right? So that's what a page is. So if we have a background here, just to make it a little bit more clear, right? So this will be like a page, right? Say, so some instructions, they take an indirect address. So what do I mean by that? So if you look at something like, and again, we're going to go back to the mass work, if we can if we can keep it open one more time. Jesus Christ, I'm gonna have to pin this tab here so I don't forget about it. So let me think of a good instruction here that I can explain to you guys. So there you go, 0 page, STA 0 page. So STA is a instruction that stores whatever is in the accumulator into a particular bit of the memory, right? So for example, if we had the value 10 in the accumulator and we do STA and then we pass in the memory address, I don't know, something like 10 here, we're gonna store whatever is in the accumulator, that value 10, right? In that particular memory address, the memory address that you provide to it. Now, STA has a 0 page mode here, which means that you can provide to it a memory in the 0 page space. So 0 page space is the first 256 bytes. That's what a 0 page is. So that's the very first page in the CPU here. Now, it also has a 0 page or absolute X here, or just absolute. So absolute X will take, instead of like a 0 page value, you can pass in any 16-bit number, which means you can pass in any kind of memory address within the 6502 CPU into the RAM that you have access to. And then it also adds the value of X to that address, right? So you can kind of, if you think of a for loop in normal programming, you can kind of implement something like, creating an array with a for loop with an STA, right? Because essentially what you're doing is like you're creating a contiguous bit in memory where each kind of byte is going to have a different value. And that's what you can kind of achieve with STA. And the X value would kind of increment every time if you think about it. So we do an absolute address of, say we want to start a position 1 here. So your code will be something like, let me see if I can display here. So it will kind of be like STA 0x01. And we also add the value of X to it, right? So that's what the assembler is kind of going to do for you. So it's going to start from this value, and then the actual place where STA is going to store that value into is this value plus whatever is in the X register, which means that if you're increasing the X register by 1 every time in your iteration, you essentially have a for loop there. Now, let me stop a bit. I'm just going to breathe and drink some water, and I'll come back to the explanation. And yeah, going back to the explanation, and this X value is going to be, increased every time. You're gonna do 1 plus 1, and then 1 plus 2, and then you get the idea. So you're gonna be kind of like walking this arrow around. It's gonna start here, and then here, and then here, and then here. So this has the potential of actually going to a different page. So say you started from the very last value here. So you store in the first value of the very last one, and then you increase X by 1. It's actually gonna go in here next, right? Which is a different page. Now, when that happens, the 6502 CPU will take longer. It just takes longer because it has to go to a different page, and it's just what it is, right? So it's just what happens. It's just defined by the hardware. And again, I have closed mass work, but if we look at STA here again, and you can see that that's reflected in the number of cycles that it takes, right? Well, not particularly this one. This one actually doesn't have that. What I explained to you, it doesn't actually have that. But some of them here, so SBC, which subtracts memory from accumulator from borrow, if you go to a different page here, It has that little star, and you can see here, so you add 1 to the cycles if the page boundary is crossed. So this is why this kind of thing gets very, very difficult. Not very difficult, but it gets very complicated and kind of hard to implement. There's loads of edge cases very easily, because every time you cross the page border, you may or may not add like 1 to the cycle. So essentially, we just have to kind of go into the code and figure out whether or not we have to increment 1 to the number of cycles taken whenever we're doing something like that in a instruction that has a page penalty. I call it that way. So whenever you go to a different page, there will be a penalty. And yeah, that's why I kind of pushed this work off until now, because it's kind of, you can get a working emulator without having to worry about the number of cycles. It's not going to be the perfect emulator, of course, because it's going to be, the timing is not going to be right. It's not going to be what you expect. It's just going to run as fast as possible. But that's why I did it that way. Now, was that clear? Did you guys understand that? Do you want me to explain anything else in better terms? Please let me know, because I tend not to be very good at explaining that kind of stuff anyway. But yeah, this is what we're doing today. We're basically going to start this work. I don't assume we're going to be able to finish everything, just because I have maybe got, I don't even know here, maybe 14 instructions implemented, and it is actually a lot of manual work to kind of go and do this stuff by hand, because there's no other way around it. But yeah, so one thing that we can do is we can just go to the simplest one. So we can maybe take a look at something like the storing functions, because that didn't really have any penalties. You can see that there's no stars here. So what I essentially have as well is like I have a different function for each of these modes. So it's fairly easy to just return the correct number for all of them, right? So we're going to look at this one. We're going to probably start with STA, and we're going to do that work. But that will also have implications on the unit tests, because I've written unit tests to make sure that STA works as expected, and things just won't compile until we kind of finish all this work. So what I'm going to do here is probably kind of create a new branch where we just do one function at a time, right? And we have that kind of this kind of rework in that branch there, just so it doesn't like mess up with the whole compilation. So I'm gonna remove whatever I added here for now, and we're gonna create a new branch where we're gonna implement that work. So do we have any changes? I just want to see what I actually changed. Okay, this is something that I don't need for now. Git stash, and then we can do git checkout -b to create a new branch, and then we're gonna call it I don't know, STA cycles, right? So STA cycles implementation. That kind of looks okay to me, right? We're gonna just push this to origin, just so we have that branch available to us, and we can start again. So let's go for it. Utility for the stuff, and actually instead of I'm gonna change that. I'm gonna change the approach here a little bit. So instead of returning an optional of tuple of size t and size t, I'm gonna return an optional of a size t, or in fact, let's create a new struct for it, right? So let's call it struct instruction, I don't know, instruction settings or instruction config, something like that. I'll probably add a better name to this later, to be honest, to give this a better name. Can't forget the semicolon here, and then in here we're gonna have the size t, so bytes read or something like that. Byte and std size it, size t, can't spell today. And this is going to be our, maybe an optional there actually. So no, the cycles, right? So this is what we're going to return here, right? Instead of the optional of size t, we're going to return an optional of instructions config. And for the sake of actually making this fairly backwards compatible because you can see here all of the functions are just kind of returning an integer as an optional. We're actually going to add a constructor to this that will allow us to implicitly convert from one integer to an instruction config, right? And essentially, our goal is to remove this constructor, but for now we're going to need it anyway. So this, let's just add it here. So instruction config. This is going to be explicit. No, it's going to be implicit, and we have a size t. Bytes is going to be simply that, bytes read, right? And we're also going to have the cycles be 0 here in this case, right? And that's it. I mean, this should make it all compile with no problem, right? Because this is just going to, oh, no, it doesn't. What do we have here? Maybe it's because we're using optional, make optional, which is a size t. Yeah, so we're going to change these into instruction config there, just to make it compile for all of these. In fact, can I change all of them at once? Let's try that. Let's try that. So we're going to change std, or in fact, just make optional of std size t. We're going to change it to make optional of instruction config, right? So that should have changed all of them, and we can build it again. Hopefully we can build it again. And I am expecting to see some errors still, because we're actually using that value. No viable conversion from return value of type enable if. Okay, so what's the issue here? So this doesn't work. Why not? We do have a constructor that takes a size t there. So why doesn't this work? So I thought this make optional stud function is just supposed to call the constructor of instruction config. At least that's what I would expect. Ah, okay, yeah, it's because we have this as well. So we can't convert from instruction set optional to optional of size t, and that makes sense, right? We just have to change that kind of value there. So we're gonna change optional of stud size t to optional of instruction config. Let's see if that at least gets us past that issue. There you go. No more issues now. Yeah, as I said, I was still expecting some issues when we actually kind of increment the PC here, because the program counter needs to access the bytes read, right? Because we want to kind of increment the program counter by however many bytes we've consumed for a particular operation. So that's what we're going to do here. And in this case, we have maybe increment bytes. Okay, so we still, what's the issue? No instantiation of Now I'm gonna ask you guys a question. Who here likes the C++ errors whenever you compile something and there's like a massive lump of errors? Like I don't even know where to start here, because that's one of the things that I hate with C++ the most. I absolutely hate having to kind of decipher C++ errors. Like I don't even know where it's beginning, so let's look at the first one. Error, incomplete type, instruction config used in type trait. Haha, template. This is not even templates, dude. This is, well, I guess it is, right? So optional is a templated structure from the stud library. But yeah, it gets a lot worse when you have like template hell. A lot worse, dude. So yeah, so instantiation of variable template specialization. Instruction config requested here. So it's saying that instruction config is an incomplete type, which is interesting because we do have it here. Instruction config, and it's definitely complete because I defined it, and it, the compiler should be able to tell the size and whatnot. So Instantiation of default member for private optional bays, cycles. Yeah, I mean this is interesting. Maybe it is worth putting some music on just for the elevator music while I'm trying to debug this. But yeah, why I don't understand why it's incomplete. Why is it incomplete? So we have CPU and we have execute next. So maybe increment comes from execute next, which returns an unordered map of instruction. Yeah, returns an instruction config, which is definitely there for sure. So this is interesting. Ah, yes, it might be incomplete because I'm not actually exporting this. So you see, instruction config is returned from every kind of instruction, right? As you can probably guess. But I'm actually using this value. Is it somewhere that's exported? Is that why it's complaining? So we have export namespace emulator. No, it can't be that either because that's actually in the implementation. So I don't understand. Do not understand what's going on here. No, definition of instruction config is not complete until the closing. Boom. So what does that mean? So what? No, the definition of instruction config is not completed until the closing braces, which is cool. Well, I do have a closing braces here, so I'm gonna have to Google this one because I can't remember how to. Never actually got this error before in C++, so that's an interesting one. We're declaring a class of type node, but that declaration is not complete until it reaches the closing braces and the semicolon. I mean, I do have that. I definitely do have the complete stuff there. That is very interesting. So what if we just kind of, if we didn't do that, would it compile? If I'm not using it, yeah, it still doesn't compile. So let's see what the error is now. Maybe we can just isolate it. Error: incomplete type instruction config used in type trait expression. Know that instantiation of variable template specialization. Is that because it's been used in the template and it has? I mean, let me just do something. Let me just do export struct. That doesn't work either. You know, out of all the things that I thought we were going to get stuck on, I didn't think it was going to be a simple struct declaration in C++, and that's definitely a meme worth having. What is going on here? This is definitely cool. Optional instruction config. Am I missing like a particular semicolon or something on this? I'm not entirely sure. What if I just remove that one? Let's see it now. Yeah, that is messed up. Yo, hello Slim. Hello dude. How is it going? Man, I'm getting too hot. Like the UK is getting too dangerously hot now. And I'm kind of sweating before I even started to actually fix the bugs, which is interesting. That's one of the things with working in the UK, guys. The UK is kind of cold all the time, and I guess the guys who live in the UK here can vouch for that. But as soon as it gets a little bit warm, it's just like hell. Like all the houses are kind of built for like the cold, so it traps the heat in. So whenever the summer comes around and you have to work in front of a computer for 8 hours a day, you'll be sweating your head is going to be very, very sweaty. Mine's not hot. Yeah, mine is hot in this case. Mine is definitely hot. Yeah, whatever happened to that guy, dude? Big Shaq, right? It was like a massive meme in the UK, and man just disappeared. Mine just disappeared. Mine just evaporated by being too hot. Yeah, that's interesting. I wonder if it's something to do with the modules that we're using, because like it's, yeah, I have no idea here. So what is going on here? Oh yeah, let's remove my actual thing. So field has incomplete type, declaring its own class duplicate. No, this is not the arrow we're on. Using pointer of class inside template. This is not it either. Yeah, I'm kind of really stuck now. What the hell? Really weird that this is not finding the instruction. Is it because of the constructor? So if I didn't have any constructor, what would actually happen? So the same error, right? Yeah, we get the same error here. Instruction config. And it is the same name, right? I'm not. Ah, yes. Ugh. See if you guys can spot the mistake. There's a very, very kind of easy typo to fix now. I'll give you guys 10 seconds. The first one who can spot the mistake here will get, I don't know, dude. You get a shout out from me. You get some praise here on the channel. No one? This is very easy actually. It's actually highlighted, by the way. Right? No takers? Yeah. I mean, yeah, I just, instead of returning a size T here, I was returning a pointer or a class to itself, right? So it kind of, if you look at this, S&T the same. Yeah, the name is yeah, I think Brock Daniel was on the right track there. So first of all, this was supposed to return a size T here. But once you actually figure out what the issue is, the message actually kind of makes sense here. It's just that it doesn't describe, the most common mistake that it could be here. So for example, we're getting the message, the definition of instruction config is not complete until the closing braces. Which makes sense because I was using it in here, right? So you can't use the class, I guess a pointer or not a pointer, but you can't give a concrete type or a member as the type of the class because it doesn't, the definition isn't complete there. I can do it as a pointer here. Yeah, you can definitely do it as a pointer, like a unique pointer. And in fact, this is how things like trees and linked lists are implemented. You have like pointers to itself, right? Because pointers are allowed in that case. But yeah, you can't have that. But it was just a typo here. It should have really been size T there. But anyway, so going back down here now, yeah, we should be able to do that. And also, actually, let's move back this definition there. Yeah, and unfortunately, as you can probably guess, with C++ it's a little bit hard because like if this was the Rust compiler, it would be like, here's a hint. Did you mean to do this or whatever? But anyway, so I expect this to go further in the compilation. It's actually linking, so it did compile fine. Now it's about linking. And essentially what we did now is like we added a backwards compatible way of kind of reporting the number of cycles that we want as well, right? So all of the functions that we had before, we have to do very, very few changes. The only change that we had to do is actually, return a make optional of instruction config instead of size T there. And things just compile. That's fine. Now, as I said, we're actually going to get into the nitty gritty of the changes. So we're going to look at the st functions. So st immediate, I think, is one of them. So st immediate, immediate, nope, sta. At this stage, because I've got so many functions, probably easier to just look for the opcode. So 85 in hexadecimal mode, what is that? 85. That's 133, right? So if I look at my list of instructions that we support, because it's essentially just a map, that's what we have here. 85 is st0 page. Right. Why did it not IntelliSense into it? st0 page. There you go. And just gonna double check this. So 85 is 0 page, yeah. So we have the std0 page there, and we have the absolute mode in there as well. So this one should actually return cycles 3, right? So that's what we're expecting here. Now what we can do here to make things a little bit even friendlier for us, we can have another constructor in this case that will also take the size t for the cycles, right? And then here we can have the cycles, which is going to be from the cycles. And what was it? It was 3. I'm not sure if you guys can see it here. So it takes 3 cycles. So it takes however many microseconds that is. So that's what we're going to do here. Just going to compile to make sure things are running fine. Okay, good. So essentially now we have a way to kind of return the number of cycles that a instruction takes in the emulator. What we don't have yet is a way to tell the hardware to wait for it. So we don't have a way to kind of say, we've run this instruction and it took 3 cycles. Now let's wait until that time, the time that's supposed to be taken is passed, right? So that's what we're going to implement here. So with that simple change, I'm actually going to have to do a little bit of extra logic here. So for example, we're going to increment the PC counter, but we're also going to have to kind of wait for the number of number of microseconds, or wait for the time the instruction should actually take here, right? Now, as I said, different CPUs, different 6502 capable processors have different speeds, right? So a very common one was the NES. So if we take a look at the NES, we're going to copy. We're essentially going to like implement whatever the NES does. So NES architecture. Let's see if we can actually find out that information. Oh no, this is not this is not the Nintendo. There you go. I just want to find out the actual clock speed of the processor. That's what we're trying to do here. Search for speed, clock. And if you guys are interested in how like a CPU actually kind of a CPU like this actually kind of generates cycles and how it ticks, that's how I call it. I'm not sure if it's the right name for it. So how each cycle ticks, you might want to look at kind of hardware and crystal oscillators, because those are what generates the kind of processor speed, right? So the better or the faster oscillators you have, the more clock speed you're going to have. That's essentially it. But do find out online if you guys are interested. It's actually a very, very interesting topic, especially for those who kind of like doing hardware. If you've done any kind of hardware before, you probably came across these terms. NES 6502 clock speed. So it's 1.79 megahertz. The Wikipedia page is actually wrong. I do remember seeing 1.69 in many different places, and if I'm not mistaken, this is the correct one. You can see that the PAL NES, or the North American NES, is actually lower than that, which is probably the reason why you have less frames per second, right? I'm not entirely sure. But on the Wikipedia page, it said it had something like 3.53 megahertz, which is like 3.5 million cycles per second. But yeah, this is the actual number here. So what we can do here is like, let's do a little trick in CMake so we can pass in whatever speed we're compiling for into the program, right? So what do I mean by that? And I'm hoping this still works for modules, because it's kind of the stuff you do with header files. So if we're gonna add an if and def here, and we say clock speed or something. So if not defined clock speed, we're going to define clock speed as 1. What was it? 1.79, right? Yeah, 1.79. End if. So essentially what I'm kind of working towards here is like I want a way to pass this value down from CMake, right? And one good way is to kind of have a default value for it in a macro defined. And if the user actually wants a different value, a different speed, for example, then in fact, let's actually change this megahertz, just to make it a bit clear what this number actually represents here. So it represents the megahertz for the speed of that, right? Yeah, so in the CMake lists, what we're going to do is we're going to pass in, we're going to maybe create an option for it where you can pass in from the command line a different speed, and then if you define it, it's going to, it's going to pass down a definition to the program. Now this has to go probably into here, right? So we're probably going to have something like add compile definitions. We have the actual emulator here. Or is it target compile definitions? I think it is target. Yeah, compile definitions, emulator. And then we have a private, and we have the clock speed, right? I think the actual syntax is like this, right? So we're gonna guard this around an actual options here. So like if we have, if the option is defined, is it end if? Yeah, end if. If defined, we're gonna pass this down now. Oop. Right? So now this allows me to kind of, to kind of pass that option down to the program, right? So I think I can put in the main CMake lists. Now this is the time to do it. This file, this project has so many files right now. I don't know why, even though it's just like one source code file. We've got so much shit going on here. Yeah, so we're gonna do it right here maybe. So we have option. And then we have clock speed here. And if I'm not, I can't remember exactly the syntax for the option in CMake, but we're gonna look at it anyway. CMake option. So out of interest, do you guys do a lot of CMake? Have you guys come across CMake before? I just want to know like the level of experience here that you guys have looking at the stream. So I expect all the C++ programmers to actually have come across CMake, of course, because that's the de facto kind of build system in C++. But yeah, so we have the variable itself, the help text, and then the default value. So if no initial value is provided, boolean off is set. Okay, so I just want to see CMake check if option is on. Okay, yeah, so I don't actually need defined here because it's going to be defined anyway. Yeah, so we're gonna take that into account. So without the default, the defined here is the right way to do it. And then we have the help text, so the clock speed for the processor. And then we have the default value here, which we're not going to have one in this case. We're just going to leave it as is. We're going to let the C++ thing define it, right? So I want to pass in a message here just to make sure this is getting actually passed. So we have status. So the clock speed was set to, and then we have clock speed here, right? So did it work? I want to see if that message is coming through because it shouldn't be coming through, right? So that's correct. But the point is, if I want to actually pass this value down from my build, right? So if I'm doing a CMake configure command in the terminal, or I'm using the CMake presets here, which in this case I am. I'm not entirely sure which one it is. Which one is it? I think it's the debug one, yeah. So I'm using the Conan debug. I'm probably using the the Unix Ninja here. Yeah, I'm not entirely sure which one I'm using. I swear the VS Code used to tell you anyway. So do we have that? Select configure preset. So we have Unix make release, Unix make debug. Yeah, that's the one. Unix make debug. Which actually comes down to Unix debug. Wait, is it? Is the right one? Select configure preset. Unix Ninja Clang release, Unix Ninja Clang debug. Yeah, that's the one. Unix Ninja Clang debug. Yeah, we found it anyway. So it is Unix deb Ninja. Yeah, working with presets can be kind of annoying, to be honest, but it is what it is, right? Yeah, so in this preset here, what we can do is we can add the variables, I think it is. So I can't remember which particular value it is now. Oh, that's a build preset anyway. So Unix deb shared, Unix deb ninja. Yeah, there you go. So cache variables. So we just basically add in here. So we can say clock speed, and then we can set it to 1.79, right? Is it gonna work with numbers? No, it doesn't. And if we reconfigure using the Clang debug, I'm expecting to see the variable coming through now, hopefully. Or maybe not. Yeah, there you go. So the clock speed was set now. And you just had basically a very quick lesson on how you can kind of pass in values from the user's configuration down to the program, right? So because we've done that, now we have access to that clock speed inside here, right? So clock speed and megahertz is going to be that particular value. In fact, it's not quite, because we actually have made a typo. You guys probably haven't figured out, but it should have been megahertz in there as well. And again, it's going to be down here too. Clock speed, megahertz. And then megahertz in here too. Right, yeah. And the last change is just this one here, megahertz. And that should be fine now. Configuration failed. Why did it fail? Why did it fail? Let's see why. Now we just have a warning there. Yeah, so the clock speed was set to empty. That's interesting, isn't it? Why is that? Oh yeah, because of this. Another typo. Megahertz. There you go. It's very, as you can probably tell, it's very fiddly working with CMake, but it works well. I actually like working with CMake because you have full control of your build environment, and you can do silly things like these. But yeah, I mean, the point is, now if we have the CPU, say we have the emulator here, right, and we also have the CPU here, we can add a new breaking change, I guess, would be, which is the clock speed. And that allows our program to have like different speeds for different emulators. If we want to have multiple of them running, that's fine as well. But yeah, and then this is probably going to be a double. Yeah, I'm going to store it as a double, and we have the clock speed here. And whenever we create this is when it's gonna bite us in the foot. So whenever we create a CPU, which is, I guess, right, what we can do is like we can just pass in the clock speed megahertz in here, no matter what. So this is going to have a default value anyway, so we don't have to break everything else when we build this. But yeah, my main point is whenever we run the program, we can kind of like do a stdout a CL here where we kind of say, you know, the clock speed is set to, and then we have whatever value it is. In here we want to have. Now, do I have FMT? I do have format. Does the format header work? STD format. Is that coming through? Why does it let me include format but not use it? So formatting C++. This file is part of the GNU. So it is finding it. So why does it not find it? Well, I'm going to try and use it anyway, right? So format, and then we can have the clock speed was set to, and then we have this. So emulator, so easy, 65K. Clock speed, is that what it was? Yeah. Now, will this build? I don't know. You tell me. I'm kind of thinking that the formatting header is not going to work, even though we're on C++ 23. So for those who don't know, the format header is essentially just the FMT library. So if you have used C++ before and you've come across the FMT library, which is a very, very popular string formatting library, that was included in C++ 23, and you can kind of use it basically as part of the STD. So it's very, very useful. But now if we run the program, let's see if it's going to work, because I'm interested to know if it's picking up the right thing. Yeah, okay, so it does kind of show it. And if we were to change this value, so say if we were to put the speed as whatever Wikipedia tells me to, right? So we have to reconfigure the project, of course, and rebuild it. And now we should be getting that value down, basically. So we made the clock speed be configurable. You know, doesn't quite work. Doesn't quite work because it's still the same value. So why is that not working? So if not defined, so this is not coming down to the emulator.cpp file, even though we have defined it. So let's see. Yeah, so we do set it to the right value, but it's not cascading it down to the actual program. And the question is, why not? Clock speed megahertz, compile definitions, private. Yeah, so this line is not kind of working fine. So let's see why it's not. Target compile definitions, that's what we're using here. So we have public foo. Let's try it without, I guess, the quotations, right? That's what it's saying here. So delete cache and reconfigure again. It's going to make sure. Again, I'm going to make sure that I can see the line here. Yeah, so I can see that it's getting past to CMake. But is it actually still running? Yeah, now it's working properly. So it's just the syntax. I guess the syntax is without the quotation marks, and that seems to work fine now. So yeah, we made it very configurable. So you can kind of pass in the different speeds if you want to compile the emulator with different speeds, right? Which is cool, definitely. But yeah, once we have all of this, we kind of know at what speed our emulator should be running. Now we actually have to make sure that each instruction takes the right amount of time, right? So we're gonna use some maths here to actually calculate that. So for example, if it takes 2 cycles, we're gonna kind of divide a duration of a second by the number of megahertz that we have, right? And that will give us, that will give us the number of cycles that we can have in a particular second for this machine. And then we're going to times that by the number of cycles, and we're going to wait on that number. That's what we're going to do here, right? So it's very, very easy logic here. By the way, are you guys still interested? Is this too boring? Please let me know. If there's anything I can do to improve the stream, feel free to message in the chat. But yeah. Oh yeah, if you haven't yet checked out, make sure you give my newest video a watch. So if you guys work with Docker containers, it's probably worth watching because I do explain what I personally do to create good Docker images. And that's my latest video. So if you haven't checked that out yet, please make sure you go on, open a new tab, open that video and leave it there. Click on the like as well. It does help me out quite a lot. Chef's kiss. And yeah, I hope you enjoy it because that video has actually been, in terms of production, it's been quite good. I mean, I've increased the production value of the videos. So I now have like an editor where this guy from, I think he's based in India. So Sandeep is a very good editor. I've been working with him for a couple of months now, where I just give him videos and he edits it for me, and it's been working quite well. I'm quite impressed with the quality of videos that he's able to edit. So make sure you check that out. That's what I'm saying. It's some sort of like, kind of looks like a Fireship video, so I was quite proud of that. Yeah. So where am I? I am on. Yeah, I'm trying to like make sure that we weight the right amount, right? So essentially, we now have the cycles. We have all the information that we need here for weighting on a particular instruction. The only thing we don't have yet is a very important header that we need. So if we include chrono, for those who don't know, chrono is a C++ standard like time header. So if you want to do weighting, if you want to do time calculations and stuff, chrono is the one you're going to be using because it's a part of, I guess it's part of modern C++, even though it's been there since C++ 11. But yeah, make sure that you guys check out chrono if you're doing anything related to time at all. And in particular, we're going to use the high-speed clock or the high-precision clock, because this is the high-resolution clock. This is the one that can kind of do the sort of weighting and time calculations that we need here. Because running 2 cycles is going to be like a microsecond on this machine, for example. So yeah. So that's what we're going to be using here. So let's work that out then, shall we? So in here we have I'm just going to do an auto const. So we number cycles to 8 or something, or cycles taken, and that's going to be maybe increment. Oh, maybe increment. This now needs a new name, I think. So the number of cycles, and yeah, this is where we calculate the number of, I guess, seconds or microseconds that we want to kind of wait for now, right? So if we know we can do something like, I think it's, do we have the emulator here? Yeah, we have CPU dot clock speed, right? So that's the number of the number of cycles that we can do per second in megahertz, right? So that is going to be times by 1,000,000, by 1, 2, 3, there you go, by 1,000,000, and that is the number of cycles per second. So auto const cycles per second. So we can do all of that, and the last final piece of the puzzle would be, I guess, the cycles to wait, right? So time to wait or something, and that is going to be the cycles taken simply divided by cycles per second. And that's what we're going to do here. So we're going to, now we're going to have to kind of use a high resolution clock to wait for the right amount of time, right? So yeah, I mean, in execute, I'm kind of tempted to just create a clock here, right? So we have stud chrono high resolution clock. Can I create it like this? I think I can, right? Let me just check the Let me just check the stuff here. Oh, in fact, we don't even need a high resolution clock. I think we can go straight away to waiting. We can go straight away to waiting in the thread. Yeah. Yeah, I think we can do that actually. So we can do something like stud this thread. Is it wait for or something? I can't remember. In fact, we need a threading header. Now we should have access to this thread. There you go. Sleep for, and then what do we need here? We need the duration, right? So yeah, so we have the time to wait in seconds here. This is going to be a very, very, very small number, by the way. This is going to be a very, very small number. Because if you just think about it, if clock speed was 1 in this case, so we did 1 million instructions, or 1 million cycles per second, then we're going to have 2 divided by 1,000,000, which is, you know, I guess a tiny, tiny number, right? In fact, let's probably use double here, just to make sure that we know what kind of precision we're using. And yeah, we're gonna sleep for this number of seconds, right? So we're gonna use the, I guess, stud chrono seconds. We can have chrono literals in here as well. Now I do want to put seconds in here. Then we have seconds, and we have the representation of seconds. I'm not sure if this can be a double. That's the thing, so time to wait. We're going to find it out. Watching this makes me want to program again. Have had such low motivation programming. Oh, Robin, dude. I'm really sorry to hear that, dude. But you know the drill, man. You know everyone goes through that. And in fact, I think, was it? Yeah, one of you guys actually messaged me personally and gave me some motivation back. I think it was Carlos, actually. And what he said was that, you know, the best thing to do is just to take some time off and then eventually just get up and do it, man. So like you just start again. You just gotta push yourself to try again, because it will come back. That motivation does come back. But I've been there, dude. You know it. You know well. You've been talking to me on the DM. So like, I've had a massive kind of lack of motivation over the month of April. So you know, basically since after Easter, I just didn't want to do anything, and it lasted for like a month. But you know, that's everyone goes through that, and it's just, you know, the life cycle of a programmer. There's not much I can say about it. But yeah, man, you should get up and you should start coding again, dude. Just do like a little thing every day and then keep increasing that amount until you get back to what you used to do. That's what I started doing. But yeah, I mean, everyone just feels overworked at some point. It's completely normal. Don't worry about it. Yeah, overworking is difficult, dude. So yeah, everyone overworks most of the time. In fact, you've just finished university as well, right, dude? So you've been overworking for 4 years, man. So you know, take your time. You have no pressure. You have nothing to to prove to anyone anymore. So you know, it's just do it at your own pace now. And I'm sure you get back to it, man. If you're interested, dude, I mean, we can work together on a project. We can, you know, I have a few ideas here where it requires a few more people. So like, if you're interested, just message me on the DM, and yeah, I'm happy to work together at some point. But I guess everyone in this chat, including myself, have gone through a period of overworking and kind of feeling low motivation. So it's normal, dude. Completely normal. But yeah. Maybe don't start with C++ though, because that will give you even less motivation, because it's frustrating to work with it. But you know, if you like it, then go for it. So wait duration, we had chrono seconds. Yeah, the only problem is that I don't know if seconds should take a yeah, it takes an int 64 here, right? So that's the duration of seconds. So maybe we can do microseconds, right? Can we do that? Microseconds? Yeah. So what is a second converted to a microsecond? So we have a second, millisecond times 1,000, and microsecond times 1,000, right? So is that it? So times 1,000 times 1,000. So second, 1 second to microsecond. Yeah, so times 1,000 squared. That's what we have here. Yeah, so we have microseconds, and then we have time to wait. And seconds times 1,000 times 1,000 times. I mean, we're really not supposed to kind of do this, but it is what it is, right? You're not supposed to do conversion by hand here, and that's what I'm doing, but it is what it is. And now we can sleep for that. So we can sleep for wait duration. You know, in theory, right, we don't actually have to wait all this time here, because this is the number of cycles that we, or the number of, or the time that we expect the whole instruction to take. But what we forget is that the C++ wrap around the emulator also takes time. So ideally, I would have a high resolution clock at the top, and then I have, you know, time now or something, so we get a time now. And then when we get to this particular line of code, we kind of get a difference of that time, you know, the time that it took for the instructions here to execute on the C++ land. And then we deduct that from this. So maybe we can do that to make it a little bit more precise, shall we say. So yeah. Let me know if it makes sense to you guys. I mean, if it doesn't, I'm happy to explain a little bit further, but yeah. So we have the time now, right? That's what we have here. So const auto const time now. In fact, this actually goes in here. This actually goes in here. So we have the time now, and then we have the time then. Auto const time then. std chrono high resolution clock now. And we can finally do something like auto const, you know, CPP overhead or something. Or CPP time. Yeah, CPP time overhead. And that'll be the time then minus time now. Does that work? I think it does. So what do I actually get here? So I get nanoseconds. Ooh, we have nanoseconds. So a nanosecond, yeah, maybe we convert everything to a nanosecond. To nanosecond. So e to the 9, yeah. So essentially we just add another 1,000 here in the time zone. And yeah, so now what we actually do is we do wait duration minus the CPP time overhead. And that should take us a little bit closer to what the hardware actually does. Obviously, we can't account for every single bit of overhead, because if we're being truthful here, this is probably going to take some time as well to calculate. Once we get a time, then anything that comes after that is going to have some overhead in C++ land as well, but it's going to be very minimal. So, and yeah, this is what we're dealing with here. But anyway, so yeah, overhead, CPP time overhead. And this should essentially be what we want, right? So I'm gonna see if this still compiles, and if it still works, just fine. No, of course it doesn't. So let's see why it doesn't compile. So error, no viable conversion from std size t. Ah, yes. So we have a problem here, because this is actually a optional, right? So we optionally give out the cycles. I'm kind of tempted to just change this to a size t now, because let's not wrap it around an optional. I don't think we need that one. So initialize, no matching constructor initialization of nanosecond in here. So what do we have? So yeah, I mean, this is going to give us a double, right? That's the problem. I mean, damn it, static cast it. Why not? Why not? Okay, yeah. So this is kind of ugly. I don't like the syntax here, but it is what it is. Yeah, let me just see if this still compiles and runs just fine. I mean, we made some changes and we forgot to actually test the program, right? So, and yeah, it still runs just fine, right? So now testing this kind of time waiting is very difficult, just because we're dealing with micro, like nanoseconds here. You know, durations that are very, 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 very small, and I guess, you know, it's going to become apparent whether or not this actually works fine when we have a game, for example, if we're simulating a game in like this is the Nintendo, the NES. You know, if the game runs at the right speed, we've done this correctly. If not, it doesn't. But for now, what we've done is we added that feature to allow for cycle waiting. That's all we've done here. So yeah, I mean, let's continue some of the work then. So we've got like all of the backbone needed for actual cycle implementations here. Now, most of these instructions will still return 0 as a cycle, because that's the default behavior here. If you've paid very close attention, you can see that this is the constructor that we're calling for all the instructions config that we're returning when running an instruction. And in fact, they should have actually had a cycles equals 0 here. So most of the instructions will be returning cycle zeros, unless I kind of manually go and implement this cycles return here, which we have done in one of the functions. I believe it was in st0 page, right? I can't remember now where it was. Yeah, st0 page. For example, this one actually returns three cycles there. So let's do more of the same. It's actually, you know, a very, very minimal change for all the functions now. So it's very, very easy to do. But obviously for that, we're going to be consulting here our trusty masswork instruction set for 65002. So for example, 0 page plus x, that takes 4 instructions, and same with the absolute, right? So we can do 4 instructions on absolute and 0 page plus x. So we have 0 page plus x, this one here, indirect. Oh yeah, let's go for the absolute. So that returns 4, right? If I'm not mistaken. Yeah, so absolute we have 4 right here, and then 0 page plus x, which is gonna be, which one is it? So what's 0 page plus x? That's 95. What is 95 in this case? I don't actually have that. I don't actually have 0x95 anywhere. Yeah, I haven't actually supported that one. So that's one of the things we don't support. Yeah, I guess that's a to-do for me. But yeah, we do have absolute plus x though, which is 5 instructions. So that's the indirect absolute plus x, and the code for this one is 9D, right? So 9D, is that here somewhere? I guess it's also not here, 9D. Yeah, nope, we don't actually support that one. We do have a few here though, absolute. Okay, I see what I did. So I basically implemented the 0 page one for STA, STX, and STY. So those all take 3 cycles, is that correct, on 0 page? So, you know, it's gonna make my life easier if I just do these ones. So A6 is one of them. A6 takes 3 cycles. Yeah, A6 takes 3 cycles. Because of the way we implemented things, it's already there anyway. 0 page plus Y. So what is the Y one? 0 page is 84, which is this one here, 0 page. So these are already returning the correct number of cycles. They all have the same one. It'll be a real bummer if they had a different cycles between 0 pages for different memory, for different registers, because that would completely break my my implementation here. So AD, which one is that? AD is absolute. So absolute. just to make sure. So absolute x here. So we use it for x and y as well. A, x, and y, they all use the same function to complete the instruction. And they take 4 cycles there, 4 cycles here, and 4 cycles here. So they're all correct as far as I can tell. Then we have st indirect, which is 91. Which one is 91? This one here. So indirect plus y. So that's an interesting one. I'm not going to explain what these modes are if you guys are interested in knowing like the different modes. So essentially all of these different opcodes here will do a different addressing mode, and some of them can be quite complicated. So like they take the value that's on the memory, and then they add that value. They use that value as the base address to store things into and add y to it. So you can look all of that online. I'm not going to bother explaining here. I mean, you guys are smart enough, right? You sound very smart to me, so you can figure that out on your own. But this one here, for example, this takes 6 instructions. So which one is that? 91. st indirect. So yeah, that's a fun one. And this is only available on STA anyway. So this one here has to return a 6. And you can automatically see that that's something that's really fun when you're writing something like this. So for example, we're writing a 6502 emulator here, and it's really teaching me how the hardware actually works and how timings actually work. So, you know, by implementing something like this, I can see why certain programs are more kind of efficient than other programs. So for example, if you can implement a program without using too many, you know, indirect STAs, so you can if you can use the other addressing modes, for example, the ones that take 3 cycles instead, it's more likely to be faster than the other program just because it has way less cycles. So it also shows you that not always the assembly code with less instructions is the fastest. So it can be actually quite slower than other programs where you inline code that's kind of taking less instructions, right? So yeah, so it's very useful for that sort of stuff. But anyway, back to this without talking too much about random shit. Recently discovered your channel. Do you still use a Raspberry Pi in dev mode that you SSH into? Hello Pedro, welcome to the channel, dude. With that name, I'm guessing either Portuguese, Spanish, one of those. But yeah, so I still use Raspberry Pis, yeah, for development. I haven't done that on stream for a while. And the reason being is because I was mostly using it for Rust development. So I was doing a web crawler in Rust, which kind of, I kind of finished it, to be honest. There wasn't much to finish it. But I do want to do some more Rust on stream, which means the Raspberry Pi is going to come back soon, dude. But yeah, I mean, there's no real difference between working with a Raspberry Pi and a fully fledged machine like this one, just because the Raspberry Pis are so advanced. The Linux distributions on those things are essentially the same as the ones you get on your normal PC. So yeah, it's kind of the same, dude. It's very easy to work on both of them. So. But yeah, however, if you wanna request a particular video on how to set it up or anything like that, man, feel free to hit me up, post it on a comment, join the Discord, and I'm happy to do like a little video or simply just teach you, dude, if you wanna like screen share at some point. But anyway, welcome to the stream, man, and I hope you enjoy it. Make sure you click on the like button for me, please. It does help me out quite a lot. And I think those are basically these ones implemented, right? So let's look at other functions that we can. So yeah, I don't want to work on the branching ones today, and I'll tell you guys why. So the branching ones have very different rules depending on the paging. So that's what I explained at the start of the stream, if you guys were paying attention. So when you go over, or when you branch over like different pages on the 6502, so if you go, if your code is on a different page, for example, it takes 2, 3, or 4 cycles depending on where you go, man. So like I'm gonna leave those for later on, so I'm gonna skip those for now. I'm gonna leave the default behavior. Increment and decrement, they sound like pretty easy, right? So incrementing instructions, they should all be like in my opinion, they should only take like 2 or 3 cycles at the very most. In fact, 2 cycles is what I'm guessing here. Well, let's look at them, right? So we can do those ones. They're not like an edge case, if it makes sense. So increment memory by 1, we're not going to look at this one. We're going to look at increment x and y. So they take 2 cycles. There you go. So each of them takes 2 cycles. Very easy to do now because we can go in here. So you can see that you have increment registers, x and y. They both use the same function, which basically means it's just a matter of me putting a 2 here. And then we've added support for cycle waiting for those instructions there. Easy mode. Right, there's decrement as well, right? So we, by symmetry, we're going to do decrement. So decrement memory by 1. We're going to skip this one for now because it takes, you guys can see here why I'm skipping it. It just has different rules for the page stuff. So, we're going to skip it for now. But decrement X and decrement Y, they both take 2 cycles as well. So we're going to put that. Decrement register, and we have 2 in here. Okay, good. Now maybe we tackle those pesky increment memory ones now. Shall we do that? I think we should do that. Let me just find it. Increment memory by 1. So the 0 page one, let's see if we can find it, which is opcode E6. In the code, we're going to have E6 in here somewhere. E6 increment 0 page. And that takes how long? That takes 5 cycles, right? So there is no star here, which means there's no weird rules. We just return 5 here. And it should work the same for increment 0 page plus X. Okay, yeah. Pedro, that's sick. Thank you. I'll definitely hit you up about that at some point. I'm still trying to learn C++ coming from odd languages. It's not my priority right now. Yeah, fair enough, dude. So, out of interest, what languages do you do, man? I kind of like to be nosy and ask people who watch me what kind of languages they do, just so I can kind of plan better for content and stuff. But yeah, I mean, learning C++ isn't bad, man. I think it's, whichever language you do, it's always good to learn C or C++ just because you get that kind of like hardware layout in your head. So like how the language actually talks to hardware, and you can understand memory at the very kind of low level. So it's always good to know those things, man. You're gonna stand out as a developer if you know those languages, in my opinion. Increment 0 page plus X. So I guess this is 0 page plus X here. So it takes 6 cycles. And then we have also absolute, which is 6 cycles, just the absolute mode. Just to make sure increments, that's F6, right? That's what I just did. F6, yeah. And we have EE, which is absolute and takes 6 cycles. So EE here takes 6 cycles. And then we have absolute plus X, which takes 7 cycles. Jesus Christ, just incrementing the value memory in an indirect mode is 7 cycles. That's a lot, isn't it? I guess that's why Nintendo games had to be very, very fast, because God, you can really shoot yourself in the foot by like misusing some of these instructions a lot. Yeah, so anyway, increment absolute plus X, that was the one I was looking at, right? Increment absolute plus X, that had 6. Absolute plus X, that was 7 here. And for those like who don't actually do C++ and you're looking at this code and you think to yourself like, God, what is he actually writing? I don't understand any of this. This is not your usual C++ project. This is a very kind of low level project actually, because we're writing an emulator, so we have to work with like raw memory. We have to do like a lot of indirect addressing. We have to do a lot of bit operations. So this is not representative of what C++ actually looks like. C++ is actually quite nicer than this if you write it properly. Like I can show you code in C++ that you can just read it like it's Python, for example. So this is just a bad example of what C++ code actually looks like. That's what I'm trying to say. So yeah. Now, it's all well and done. We can kind of just do this for the rest of the stream. I'm gonna like spare you the boring details. I'm gonna do the rest on my own. What I do want to mention as well is like we can actually add these cycle tests to our instruction test, right? So every single instruction that I've added so far has a unit test. for example, we've done a lot of work on incrementing stuff, right? So if we look at my tests here, I should have an increment tests where I have very exhaustive tests for every single possibility that you have when things cross like the 0 page. Not in this case because it doesn't have any addressing modes, but when things cross like 0 pages, when you have like flags being set, I've added tests for every single one of those things, which makes this library possibly the the most well-tested emulator out there, because I've read some of them, and yeah, they're quite buggy sometimes because, you know, lack of tests and whatnot. But it also means that I'm taking forever to actually finish this project, which, you know, it is what it is, right? You can't have both ways, I guess. But we can include all the cycle stuff in our unit test. Now, for example, if I were to call, if I were to include some of the tests here on, you can see, so incrementing X and no flag set. We don't have any tests for the actual number of cycles taken, right? And in fact, we can't even test that now, just because I guess we don't really expose the cycle stuff at all to the user. But if we were to do that, if we were to somehow export the number of cycles taken here, so maybe increment, I don't know what this function is actually returning. Oh, yeah, returning a boolean here. So maybe we can actually return the entire well, the sum of the cycles taken, right? So let's do that. So instead of boolean, again, if I make that change, it's going to break a lot of tests of mine, so I'm going to wait a little bit. Started with C, then did projects in JS, Python, and Java. I stopped coding for a while, and it feels like I need some time to get back to any of those. Trying to learn. I can't see the thing because there's C++ and low level now. Yeah, sounds like a good plan, Pedro. I mean, you know, you probably know more than anyone else, dude. So practice is key, right? So if you do something over and over again for a long period of time, you eventually learn it. And that's, you know, that's what every good programmer had to do at some point. I want to remove this heart thing. So how do I do that? Where is the inspect? There you go. Please tell me I can remove that. Hide. Hide element. There you go. I can read your messages better now, dude. But yeah, I mean, this is something I say on stream over and over again. Like, for those who are watching me and kind of want to be on my level, and kind of assume that I've done this from like day to night, so I just got this good in like a year. It's a little bit harder than that. You just gotta practice over and over again. You gotta like apply yourself. You gotta learn, you know, some theory. You gotta just code for years. Then you'll be a good programmer. Not that you can't be a good programmer by doing it for a year. You can still be fairly good by just doing programming for 6 months. But what I'm trying to say is that everything takes practice, everything takes time, and that's the most important thing. Everything takes time if you do the practice. Now, if you don't do the practice, it doesn't matter how much time you wait, you'll never be good at it. Now, if you practice consistently all the time, then you'll be good at it eventually. So, and this applies to anything, not just programming. Not just programming. The biggest problem that I see with beginners is, you know, another thing that I talk a lot about on stream is people giving up before they actually become good at it. So if you want to be good at it, dude, just don't give up. Just keep going. Yeah, so I'm thinking very hard if I want to kind of change this to a size T here. And I don't think that's going to break a lot of stuff, though. Let's see. I don't think it will break a lot of stuff because... Oh, it will. It will break a lot of... No matching constructor initialization. What the hell? What's going on here? So candidate constructor not viable conversion for int. First of all, let me change this. Yeah, so why is it not working? Instruction config. We do have size T and size T here. Seconds and seconds. So why is this not returning? Right, candidate construction template not viable. No known conversion from int to in place T first argument. Could not match initialize a list against int. requires one argument but two are provided. Candidate constructor template not viable, requires argument T but two arguments are provided. Yeah, so for some reason it's not following my other constructor here. That is interesting. That is very interesting indeed. No, candidate constructor, implicit copy constructor, not viable. Requires one argument, but two were provided. Oh. The implicit move constructor not provided. Okay. Why is this not working fine? Why is this not working fine? I mean, ideally, I'm expecting optional, make optional. Ah, okay, because it's optional, and that's why if I did make optional, then it would make sense. Yeah, that explains a lot of things. So, you know, I've explained this to you guys in the past stream, I think. So optional is very kind of fiddly to work with in C++ because it's, you know, in essence, it's a good type. Like it's essentially an alternative to something like result in Rust or whatever equivalent you have in other languages. Obviously now we have expect in C++, which is kind of what result does. But optional is like a way of you telling C++ that you may or may not have a valid type, right? And if you use optional on its own, like something like this, it kind of works fine if you have like one argument that you can implicitly convert. But it kind of doesn't really generate very efficient code. So this is not going to call on things like return value optimization for you. And in fact, if you have like a constructor that takes multiple arguments and is not implicitly convertible from these arguments here, it's not going to work. So you just have to call in make optional. So make sure that you use make optional whenever you can in C++ because, you know, it's kind of the way to work with optional anyway. There's a very good video by Jason, I think, Jason Turner, which is very big in C++. He's like one of the biggest C++ speakers out there. It explains what happens here very well. Let me see if I can find it here for you guys. I'm just going to post it on the stream because I think it's a very, very useful video to actually look at. So C++ weekly optional. It was a very recent video actually. I remember seeing it.
VFly is a company.
There you go. So this is a good video to look at. I got a few messages. So yeah, willing to put in the time. Do you have any recommendations for systems and embedded programming? I see you talking about cycles and whatnot. Got to learn some hardware, I guess. So I mean, to learn C++, you don't really need to kind of learn hardware. You can use C++ in a very sort of high level way. Like you can just use C++ to make any sort of project you can make in other languages, right? I mean, even websites you can do with C++. I've got a video on making like backends of C++, which is actually very interesting if you're into that sort of stuff. But if you like hardware, man, what I recommend is like the way I learned hardware is simply by getting like a microcontroller of some type or of some sort. A very good one to have nowadays is the Raspberry Pi Pico, just because it has a very good ecosystem and it's very easy for you to create programs for it. There's like very kind of up-to-date compilers for it. But you know, there's a bunch of like microcontrollers you can use to actually learn hardware, and yeah, I mean you can play with C++, compile programs for the Pico, for example. You can make it like turn on some LEDs and stuff, and you know that it is definitely a good way to learn because you can kind of see physically what you're making, as opposed to just making a high level project, I guess. But yeah. Now, in terms of recommendations, what I actually do, I mean, what I actually do, man, is like I just pick a project and start making it, man. So like if I'm learning a new language or something, I decide on what I want to make with that language and I just get into it. Obviously, I use things like books and documentation online to kind of support my learning because you're not gonna know everything when you start, right? In fact, you're gonna know very little. So it's good to have those resources, by your side, just so you can kind of get going. And if you know someone who knows these languages as well, it's worth just keeping in touch and asking them questions. So for example, you're welcome to like join the Discord channel and ask me questions in there. Either me or someone else in the channel. Like there's quite a few people who do C++, like Robin here. is usually online too. I'm sure that someone will be able to help you, man. So yeah, we're a very sort of like open and friendly community. So anyway, back to this. So we have st indirect. I forgot what I was doing now. You know, I completely forgot what I was doing. Yeah, so we had make optional here, and that's why it wasn't compiling before, and it made sense. Yeah, so what I was actually trying to do is like in the end, at the end of the day, I was trying to make this a size t. So I'm gonna compile this. I'm pretty sure that I'll break all my tests now because they're all kind of expecting this function to return true, and yeah, and whatnot. So you know, changing it from bool to size t does compile is not ideal because it doesn't really have the same behavior as before. Like I may be returning 0 for a program, for example, if I run a particular 6502 program that I haven't quite implemented the cycles yet, it's going to return 0, which is a false, which in the past kind of indicated that the program failed. You can see here, so return false here. And, you know, it's not ideal, I guess, but we can work with this, right? But anyway, so in the end, what I did actually want to do is like I wanted to have a variable here called maybe a stud size t. So end cycles, and we're going to start that with 0. And every time we run something, every time we run an instruction, so say here, we can do end cycles plus cycles taken, right? And at the very end, instead of returning true, we're going to return the end cycles. Yeah. And I think this is a little bit better now. Now, as I said, I'm going to run all the tests here, and you see that a lot of them will have broken. Oh, maybe not. Maybe I wasn't even checking for the for the execution at all. So I haven't actually broken anything, which is good. But this allows me to actually go back to my increment tests and checking that I have actually kind of executed the right number of cycles that I expect, right? So let's do that. Just so I can show you guys on stream how you approach doing something like this, because yeah, it's important to actually update your test if you've implemented something new, right? So that's why I add one here. So if you're wondering what this comment is here, this is basically for Clang format. So sorry, not Clang format, Clang tidy. So Clang tidy actually analyzes all the C++ code and makes sure that like your naming or your functions are properly defined in the correct way, and it checks that your code doesn't have any like static analysis bugs in it, basically. So you know it just statically analyzes your code. If you don't know what that is, just look it up because I can't be bothered explaining. But it turns out that the gtest library actually does have quite a few issues with Clang format, and hence why we have to skip it. And this line does just that. It skips the definition of the test. That's all. So increment x, correct cycles. I'm just going to copy this because I want to see if it kind of works. I'm going to strip this test down a little bit, actually. So instead of having that, let me see. So increment x and the start of x. Okay, yeah. So what I'm going to do is I'm just going to have one of these values here. So I guess auto or stud array std int 8t. Ooh, and then we have 1, which is the size of the program, and we're going to call that program. And that's what we're going to have here in the program. That's all. That can be a constant as well. We don't need this anymore. I don't need any of that. Again, this test is just going to be checking that once I execute a program, it's going to return the right number of cycles, right? So for example, auto const cycles, we're going to execute that. We don't have it in the x, we don't care about that anymore. gonna inline everything here. We don't care about the registries anymore. So what I'm really wanting to check here is that I can do an assert equals. I can make sure that the number of cycles is equals to 2, right? If I'm not mistaken. So let me just figure out here. I think it was 2, right? I remember now. Increment x, yeah, it's supposed to be 2. So this is supposed to take 2 cycles, which means my emulator is supposed to return overall 2 cycles because I'm only running the program, right? So we have program data, program size there. And that's the test. That's essentially the test. And I have to do this for every single instruction that I've ever supported, which is going to be annoying, but it is it is what it is, right? But yeah, I mean, if I build it now, it should still build, hopefully. Yeah. And if I run the tests on the increment test here, if I run it, it works, right? So my test works. And this is the kind of logic that you kind of have to just add manually now. So again, I'm not going to do all of these on stream because it will take hours for me to complete every single instruction that I've made so far and to make sure that they are returning the correct number of cycles. But this is just a kind of a way for you to see that you've implemented the correct thing. So ideally, I'm going to go back and forth on this website here, make sure that every instruction is returning the correct number of cycles in the end, right? And that's it. I think I'm going to call the stream here, guys, actually. So it's been a good stream. I mean, I've got stuck in very few things today, so we actually managed to get a lot of stuff done. But yeah, let's just push this code and then we can chat a little bit more. So if you guys have any questions before the end of the stream, feel free to join to post it now. Once again, thank you everyone for watching the stream and making sure for watching the stream and sticking around because it's been fun. I've enjoyed talking to most of you. Again, I'm running Clang format here just to format the code, and then we can push the code around. By the way, if you guys are interested in helping out on this project, if you are interested in seeing what the code is like, there is a link to it in the description, so you can see the GitHub link on the description of the video. So feel free to go in there and make sure you hit that like button on the video, and also make sure that you guys hit the star button on the GitHub. I'll appreciate that very much. And that's it. I'm gonna push this and then we'll call out the stream. I'll wait for more questions if there's any. I don't think there is, but yeah. It's going to be a lot of files to change now, so git add 1 to 6. Do we want to add everything? I think we do, right? We want to add every change here. So what did we actually do? So we added support for reporting number of cycles per instruction. So what have we actually done? So we changed the instruction definition to account for cycles. What else did we do? We changed the exported execute function to return overall cycles executed. We added support for waiting for the right number of nanoseconds per instruction. And I think that's pretty much it, right? So we can do it here. So oh no, what have I done? I made a mistake. Git commit. There you go. Let's push it. I'm gonna just create a final PR here just to make sure that I don't forget about it, because if I don't create this, I'm 100% never going to look at it again, which means this feature is never going to be implemented again. But yeah, support for cycle time. Yeah, so let's create that pull request. And yeah, I mean, it seems that we have no questions. But yeah, thank you all very much for joining. And I guess I'll see you guys next time. Once again, have a good weekend and bye-bye. Ciao.